Hi all, let's see the implementation of log variable solution. So before an critical section, there is a section called entry section, and after the critical section, the section is called exit section. So critical section is always present between entry section and exit section. Okay, and critical section can be any shared resources or shared files which are shared between two or more than two processes. Okay. So for understanding this code or this implementation, let's take an example. Let's say we have two processes, process P1 and process P2, and both the processes, process P1 and process P2, wants to access this shared resource or critical section. Okay, so for that purpose, they both want to compete each other. Let's say process P1 gets a chance first, and initially log value will be 0. So at the initial phase, any process can enter the critical section. There is no problem with that. So let's say here the condition is while log is not equal to 0. So log is equal to 0, that means this condition particularly is failed. If this condition fails, then process P1 execute the line number first successfully, and then it will execute the line number second also, and it will make log is equal to 1. Okay, and it will successfully enter the critical section. Okay, maybe it can the critical section contain the printer which are shared between the two processes. Okay, and it will use the printer. Okay, and let's say after using the critical section, okay, it will be preempted. Okay, let's say CPU or operating system preempt this process. So what happened? It will present in the critical section, okay, but it will not leave the critical section. So whenever the other process wants to or try to enter the critical section, they will stuck at the while loop. Okay, so let's say process P2 and wants to or try to enter the critical section. So here the condition is while log is not equal to 0 but log is equal to 1. That means process P2 stuck is in this while loop, and it is stucking in while loop called as infinite loop. So here the problem is whenever a process is present in the critical section, the other process continuously busy trying to access the critical section. Okay, and for that reason this log variable solution is also called as a busy waiting synchronization solution. Okay, and assume that process P1 completed their execution in critical section, so they wanted to leave the critical section, so it will execute the line number 4 and made log is equal to 0 again. Okay, so what happened? If log is equal to 0, then this process P2 which are stuck at while loop at line number 1 will get a chance to enter the critical section. So process P1 execute the line number 1, then line number 2, and then enter the critical section, and then after use the line number 4 to leave the critical section. Okay, so here it represent this particular loop represent it is a busy waiting solution. Okay, but this log variable is having a problem called the mutual exclusion problem. The primary condition or the primary requirement of synchronization mechanism is that every synchronization mechanism provides two primary requirements. One is mutual exclusion and the other one is progress. Okay, one is mutual exclusion and the other one is progress. So this particular solution does not provide mutual exclusion. How? Let's see the assembly code for this log variable solution. So it is a high level code. I want to show you that the assembly code representing this high level code will be look like this. So here I will already write the assembly code of log variable solution. The line number 1 says load log value into register R0. So let's say we have a register R0. In this register R0 we will load the value of log. What is the value of log? Initially the value of log is 0. So 0 will be loaded in register R0. Okay, and let's erase this solution. Okay, now after that it will compare, second line says that it will compare R0 value with 0. Okay, so here hash indicate in assembly code, hash indicates that we compare the value with a constant value. So whenever a particular variable or register contains some value, then we will compare it with the constant value. So if register R0 contains 0, then we will go to the step number 3. Step number 3 says that jump if not 0 to step 1. If the value of R0 does not contain 0, then we will jump it to line number 1 or step number 1. Okay. Otherwise, we will go to the step number 4. Step number 4 says that store 1 into lock variable. Okay. So here lock variables is 0. We can easily store them into 1 and then enter into the critical section. So if lock variable contain 1, then whenever the other process wants to or try to enter the critical section, they will not enter it. Why? Because the lock variable itself contains 1. And the previous process which already entered the critical section can use this critical section, and after their execution is completed, they will easily leave the critical section by again storing the value 0 to with the variable lock. Okay, so this is the assembly code for lock variable solution. Now let's see with an example how this particular code have some disadvantage or drawback. So let's again take the two processes, process P1 and process P2. Let's say process P1 wants to enter the critical section and it will execute the line number 1. Okay, it will execute the line number 1. Line number 1 says that store the value of lock variable to the register R0. Okay, so we will store it the value 0, and after that it will preempt it. Okay, it will be preempted by either the processor or CPU. Now after that, after the preemption of process P1, process P2 will get a chance, and process P2 will execute the line number 1. Okay, and it will execute the line number 2. Line number 2 says compare R0 with 0. Yes, it is 0. R0 is 0. And it will execute line number 3. Yes, it is line number 3 is step jump if not 0 step 1. If it is not 0, then go to the step 1, but it is 0, so we can successfully execute line number 4 also. So process P2 execute line number 4 also, and it will made lock variable value as 1. Okay, and then process P2 enter the critical section. Okay, so process P2 enter the critical section. Okay, now assume that process P2 is enter the critical section and again it will preempt it. Now process P1 get a chance again. So process P1 already executed the line number 1. The line number 1 says that it will store the value 0 to the register R0. So it will execute line number 2 also because register R0 contains 0. It will execute line number 3 also because register R0 does not contain the value 1. It contains the value of 0, and it will also contain the execute the value. It will also execute the line number 4 also, and it will also enter the critical section. So you got the point here. The problem is both the processes, process P1 and process P2, are simultaneously entering the critical section, which violate the rule of first rule, the primary rule. The primary rule says that only one process can enter the critical section at a time. That is called mutual exclusion. So here the lock variable does not provide mutual exclusion. So it fails to provide mutual exclusion. So if any synchronization mechanism does not provide the primary requirement, then there is no need to talk about the other things like secondary requirement or other particular things. So here itself we will stop this process and move to the next synchronization solution. So it basically fails to provide mutual exclusion, and mutual exclusion is our primary requirement for any synchronization mechanism technique. Okay, so if any, let's say if there are n number of processes are available in the operating system, and this lock variable definitely allow n number of processes. So process P1 execute line number 1 and halt again process P2 execute line number 1 and halt it. Process P3 execute line number 1 and halt. So similarly, if all the n processes are executing the line number 1 and halted, then when their chance come next, or whenever they came next, then all the process simultaneously enter the critical section and share the resources. Okay, so this is the major drawback for this local variable solution. That's why we are not using this local variable solution practically. Practically we are not using it. Practically we are using Peterson solution. So in the later videos I will show you how Peterson solution is practically implementable. Okay, so in the next video we will see the next synchronization mechanism technique with busy waiting mode.